Good morning, everyone. Thank you. Rest of you, good morning. There we go. So hopefully you're all in the right spot. Angular unit testing. How many of you are doing unit testing today in Angular? Awesome. So then you know this. Unit testing is nothing more than proof that your code does what you actually think it's doing. We have a few tenets we're going to talk about. First, they have to be automated. We want them to be isolated. You shouldn't be testing your services from your components. Your service shouldn't be calling your database. Those things are end-to-end testing. Those aren't unit tests. Unit tests is single points of work, single assumptions. We want it to be consistent. No matter how many times I run them, I should get the same result. Need to be easy to read and write. Unit tests are a great way to document functionality. We shouldn't have trickery in our unit tests that makes us have to try to decipher it. And then for writing, the easier it is to write, the more chances your dev team is going to actually write unit tests. Our failures should also point to problems. They should not point to stack traces in the testing framework. There's a few frameworks out there that do that and it drives me nuts. I'm like, now I got to hook a debugger up and rerun my test and hope it fails again. We want it to be fast. If your unit tests take a few seconds, you're going to run them and potentially even leave them running. If they take minutes on end, you're lucky if your developers, including yourself, run them even before you push your code. First and foremost, though, unit test will never fix your bad coding practices. No matter how many unit tests you have, if you aren't following the Angular standards, you're doing a lot of trickery in your code, unit test won't fix any of that for you. We're going to cover 4 patterns today. There's a total of 6. Due to time, we're only going to do 4. We'll look at modules, components, services, and routes. You can also test pipes and our route guards. Setup-wise for our code, we're going to use the Angular CLI. When you generate a project with the CLI, it gives you all the testing stuff wired up. When you generate new components, services, pipes, guards, they all give you the test specs. Everything's there. You don't have to think about it. Obviously, we need Node. We need 6.9 or greater. That's an Angular requirement for Protractor. To get the Angular command line installed, npm install -g at angular/CLI. When I generate my new projects, it's ng-new, give it some name. I like to use Sass for all of my style sheets, so I do the -- style SCSS. And I wanted to create a routing file since I'm going to have more than one component. And that's what the -- routing would do. Then to run our test, the command line, do an npm test. It will do all of our compilations and kick off all of our tests. There's a few tools included. Karma is our test runner. Jasmine's our testing framework, so we're going to get all of our expect statements from. And Angular includes a bunch of testing utilities. Stuff to instantiate modules so you don't have to include every component under the sun for your whole app just to test one component. You got a bunch of stuff around routing to hide complexity. We'll see a bunch of that stuff throughout this. When you run your npm test, get a window very similar to this. Compiles everything. The very last line says executed 46 of 46 successfully. If there was any errors, it would show you the stack trace in the command line. Not the greatest view. This is a much nicer view. It automatically will open up a Chrome window for you when it starts running all of your Karma tests, and will show you each of your groupings of tests. Will show you any errors, show you all of the stack traces for it, and you can click into the individual ones to see what actually happened. You can also click the debug button that's up in the upper right, open up the Chrome debug tools, and put all your breakpoints, look at code, all the standard stuff you're used to in the Chrome debug tools, or dev tools. Coding-wise, this is what a Karma test with Jasmine looks like. We start with describe. That's the grouping of tests. We give it some name, whatever name we want to give it. In this case, I called it first spec. And then we have our arrow function. Within our arrow function, we're going to have 0 or more tests. Technically, you don't have to put any test in the describe. Each test starts with an it. You give it a name. You give it our arrow function. And then we get expect statements. In this case, I'm saying I expect true to be truthy. So true should be true. They have all kinds of other expect statements as well. I can tell it to equal something. I can tell it I want it to be something. I want it to be false. When this test runs, I'm going to get windows similar to this. It tells I ran one spec. It tells me my grouping for the describe, which is first spec, and then tells me the test that ran. If I switch this test up, and I say I expect false to be truthy, obviously it's going to error because false doesn't equal true. I get this stack trace. Still gives me my grouping. The very line right above the arrow says, first failing spec should fail. So it tells me what is my describe and what is my test, and then gives me the error message in the whole stack trace. And I can start doing troubleshooting. All of our tests for the rest of this presentation are all going to have that same setup. We're going to have a describe, and we're going to have an it. First, we're going to look at components. So standard component here. We've got our imports for component on an it, got our decorator for component, got our class, constructor, ng on an it. Nothing tricky here. Two things I want to call out. We're using external templates. That is the default for the command line. That is also my preference. And then I have a variable called subject within my class for my component. So we want to test that our subject is actually going to be set to world and that the UI is going to output hello world. The template side says hello, then my subject and an exclamation point. So first thing we have to do, configure the module. I have to tell Angular, how do I load this test up? So very similar to what we saw before here. We have a few imports. We're going to pull in some Angular testing utilities. We do async, a component fixture, and a test bed. And then we're going to pull in our component. Get our standard describe. Now we have a before each. This is going to run before every one of the tests. Great way to reset all of your configurations before each test. And a very important thing here is the async. Our templates, because they're external, that's an asynchronous operation in Angular to load those up. And so we have to tell our testing framework, I need to load that piece of it asynchronously. And then we're going to use another Angular testing utility called TestBed. That's how we're going to create a testing module so that I only need to pull in exactly what I need for this specific test, which in this case, I'm only pulling in my simple component. I don't need to pull in any services, pipes, any of my providers. None of that needs to be in here for this specific test. And the test bed will allow me to add those things as I need. So we'll see later on, we'll add some providers in, we'll add some import statements for some additional modules. Then the last thing we have here is the .compile components. That says, go read my external template, do all of your Angular stuff to make it in memory so I can use it. Now that we have our module configured, we actually need to create a test fixture so we can get access to the testing environment. This is what we had before. Now we're going to add a variable to hold our fixture, which will be a component fixture, and you tell it what type of component. And we have another before each without the async. So the way Jasmine will work, it'll run our before each async. Once that's done, then it will go on to the next before each. And here we can tell it, create our component. Give me access to the test environment. The third thing we have to do is we have to actually get an instance of our component. Because right now we're only in the test environment. I need to be able to access that subject variable in my component. Just instantiate a variable for the actual component. And then inside my second before each, I use the fixture I defined. I say .component instance to get my reference. So pretty easy to get the component instances that already created it. Now I'm ready to do my test. Standard it statement with a name, arrow function. The simplest test I can run for a component is that I expect the component to be truthy. I could actually instantiate the component is what this is testing. The very first test that they give you when you generate components in the Angular command line, and I always leave it in there. It makes sure that you didn't forget to accidentally put something in your test module, some dependency or something else, and I can verify really quickly, yes, the component works, and then the rest of my tests, when they fail, I know it's not because I couldn't instantiate. The one thing we haven't done yet, though, is trigger any kind of change detection. So even though our component got created, it didn't trigger change detection, which meant it didn't run anything in my ng on init. So I need to tell it to trigger that. It's as easy as in the before each, right after the component. I use the fixture again, and I say .detect changes, and that tells Angular, go and run the whole change detection cycle and do all the stuff you would normally do, which includes running ng on init for us. Now I can look, if I need to, at the actual component's DOM. So I can test some of the HTML that's in the template if I need to. I try not to do a ton of HTML testing. I test the critical stuff in the HTML piece. It really feels like HTML testing gets into end-to-end testing. But if I have specific pieces that I want to test, like I've got some pages at work where depending on what you pass in for the route, it will change the content that's on the page. So I need to test the different route parameters that we can pass in to make sure at least the header is on the page. If the header's there, I assume the rest of the content is correct. And to do that, I need to use a couple elements. So this is the test we had before. Now we need to import two things. I need to import the by out of the platform browser. So this will allow us to do queries like by CSS and give it some tag or element or class. Then I need the debug element so I can get access to actual components and input tags and elements on the page. So create a variable for the element. Before my fixture.detect changes, I want to say element equals fixture.debug element. Now I can access anything that's on the actual HTML template. So our template that I'm testing has an h1 tag. I'll say hello, whatever our subject is, with the exclamation point. So test this, standard it statement. And I say element.query by CSS h1. This will pull all of the h1 tags. Because I only have one, I'm only going to get one back. Then I can say, give me the native element, which will be the HTML input, or the HTML tag, and then give me the inner text of it. And test that it's going to be hello world exclamation. So that I know my subject's getting set in the right spot. Making sure I don't have some spaces after the subject. You know, when I was creating this for the presentation, I thought this is kind of a silly example. And what did I do the first thing I created? One of my tests, I put a space after the subject between the subject and the punctuation. I was like, that's kind of dumb. And then I went, that's why I have the test. So small things like this are easy to test, make sure users get stuff right. But it's rare that we have a component that has zero dependencies. A lot of times we're pulling stuff out of services, out of our databases, putting them in the components. So simple service, we're going to take our subject here, put it in a greeting service, and we're going to leave it still set to world. Now we're going to have a service reference. So our component, standard stuff, import our service, throw it into our constructor for the dependency injection, and change our subject to get the actual value out of our service. Nothing tricky here, standard stuff. Where it gets a little trickier, you don't want to actually use the real service in your test. We talked earlier, it should be isolated. Your component's not meant to test the service. Your component is meant to test that everything's wired up correctly for the component. So we want to use either a stub or actually spy on it and replace what is getting returned. So first look at what is a stub. I call them stubs. I've heard other people in Angular call them stubs. They're really mock objects in the unit testing world. So I create a mock greeting service class. I put the subject and I give it some value. I want to definitely make sure my value though is different than what I hard-coded in my service, so that I can make sure I actually called my stub and I set it up right and I didn't accidentally call the service. That's much more obvious when you're going against a real API that touches a database, when you don't have the database connection configured and it just errors. That's really obvious that your stub wasn't working. But when you're not going against something like that, you want to make sure the values are different. From a testing standpoint, this is what we saw earlier. The one line that's different is we have a providers line now. Instead of just saying providers and giving it the class, we give it an object where we say provide the greeting service, but we're going to use the greeting service stub class anytime that I request something out of greeting service. So from a test standpoint, there's only one difference in this test. It's our to be statement. Now it's going to say hello test world because that's what our stub has in it, as we can see from the stub here. So nothing really changed with our test at this point, which is really awesome. Easy way to do mocks and not have to do a lot of stuff with changing test around. Service spying, a little different. So we're going to change our service up a little bit. And going to make it more observable based. So we'll put in our greeting, our subject, and our punctuation here, return some observables back. Typically, this is where you would make an actual real HTTP call to your database and get data. And we'll change up our component a little. Create 3 variables to hold our stuff out of our service, and the typical subscribes to get our observables here, and then just set, for the result that comes back, set the appropriate variable. Very standard stuff for how you would do any kind of calls to something that returns an observable. Test standpoint, a little bit of changes. So now we need a variable to get a reference to our actual service. Our providers, back to what we're used to. We just put the service name in there. Put in our before each. Now we're going to look at our debug element and say, look at the injector and get me out the greeting service that you injected. The other thing to call out here, at the very end, right after this, there's no more fixture.detect changes. We're going to actually put that into our test. So our test, standard if statement, but now we're actually going to do an asynchronous call here because observables are asynchronous. And the SpyOn is something that's built into Jasmine. We don't have to import anything or do anything strange for that. It just works out of the box. And we say SpyOn the greeting service and the getGreeting function. Anytime that's called, I'm going to return a value of the observable.of hello. So now I want to do my fixture.detect changes. And the reason I want to do it in this order is because all of my calls are in my ngOn init. So the minute I call fixture.detect changes, it runs ngOn init. And if I don't have my SpyOns created, it's going to go ahead and actually call the real service. So technically, I need to put all the spies here for the ngOn init, but for brevity's sake, I just put the one. Now I start getting some asynchronous code in here. I have to say fixture.whenStable.then so that it will track when is all of the observables and promises done. Then I want to run the rest of my testing code. Then I run another fixture.detect changes to make sure anything that came back gets run through the detection cycle. Then I run my expect statement. I say component.greeting, I expect it to be hello. But this is kind of annoying to have to put in this fixture when stable stuff. Really in our test, we don't want to put in asynchronous code and make us have to look at this. Thankfully, there's a way around this. And it's called FakeAsync. So we import 2 things, tick, which is a utility that Angular gives us for testing, basically forwards time is what the purpose is. And then we do our standard it statement. Instead of async, we put FakeAsync. Nothing changed for our spy, but what changed now is instead of having that when stable then, I say detect my changes, run the tick so it forwards the time, which basically finishes all of my observables and promises, do my second detect changes, and then I can do my expect statement. So it makes it look much more like synchronous code. I don't have to try to figure out, well, when does this when stable thing actually run? You know, that's a little confusing. Every time I see it, I'm like, okay, how many things are running before this? You look at this set of code here, you can just see straight down. It's going to run one after the other. So this is the preferred way in most cases so that you don't have that when stable. So before we go to reactive forms in a component, any questions on component testing? That is a great question. So the question is, I've seen tick, flush, and flush microtest used interchangeably. I just found out about flush yesterday, actually. I was doing a little research for something. Flush is something new that's in Angular 4.2, I believe, that essentially replaces tick to say, flush all of my asynchronous calls and make them complete so I can go on with the rest of my testing. And so it seems like that's going to probably replace tick for a lot of these ones. Just seemed like it was a little new. That is one of the problems right now with Angular unit testing, is they're moving at such a rapid pace for this stuff that a lot of times their docs aren't really keeping up. So they have we'll see it at the very end, the link to the Angular testing guide, and they don't even mention a lot of this stuff in there yet. That they have actual comments in their code samples say, in the future we will change it to X, Y, or Z, and it's like, okay. So they're definitely moving. It seems like flush is going to be the new replacement. Any other questions for components?
At this point, everything you've done is out of the box Angular CLI.
Everything you're going to see here, except for 3 helper functions, is 100% out of the box. And the helper functions, really, they're technically used to be out of the box, and they got rid of them, and I thought they were useful, so I brought them back. Anything else for components? So reactive forms. Hopefully we all know there's 2 types of forms in Angular. There's model-driven forms and template forms, or model-driven we also call reactive. You can't test the template-driven form, so I'm not even touching it in here at all. Reactive forms, you can fully unit test it. So we can look at stuff like my validation errors. I can look at every field that I put a validator on, and I can trigger the different validations and make sure that they triggered like I expected them to trigger. You can look at the field. If all of my validators pass, is my field valid? If all my validators for every form field pass, is my form now valid? I can look at specific error messages. So I typically have a very generic error trap that loops through all of my controls and looks at what the error messages I want to spit out are for the different validators. I can validate that those messages are coming out correctly. I can also validate, did they show up in the UI correctly? Now, just because they triggered that the message was supposed to be there, is the UI actually got the right one? If I'm supposed to be appending together all of my validator messages so I get one message and not, oh, you fixed this validator, now I got to go type something else, now another validator. Like, that's horrible from a UI user standpoint. Like, just show me all the errors at once. I can validate they all showed up. From a component standpoint, standard stuff here. Import our form group, form builder, validators from Angular Forms. I do, in my actual module, have to import reactive forms, but that's for the whole app. And then I also like to import the debounce time so that I can tell my UI, wait a second or 2 seconds for the user to stop typing before you show the validator messages. It's really annoying when I click on like an email field and it instantly goes email required. It's like, yes, I kind of know that. I just clicked on the field to type it in. Can you give me a sec? So I always throw that on there. And then we do our standard dependency injection. I need the form builder. Then I'm going to create a variable to hold my form. In this case, the form has one field called item. It's going to be blank by default and has 2 validators. It's required and it needs a minimum length of 3. And the other thing I do, so I talked about the debounce time, is I hook it up to the value changes, tell it wait a second, and then subscribe to that observable and run all of my validation so I can get my error messages spit out the way I want. And we'll talk about debounce time here in a few slides. From a testing standpoint, a few things changed. I need to import the reactive forms module. I need abstract controls and validators. Now my TestBed config module, in addition to declarations and providers, I need to put the imports to pull in the module. And then I'm technically ready to test, which is what this one is. So the item field, because I only have one field and all of my tests are going to be testing something on that field, instead of having every single test say, hey, get me my form control called item, I put it in the before each so I have access to it, and it's only in one spot. Then we have our test. Standard if statement, there's no async or anything on this one. I want to set my value to something. In this case, I'm going to test if my field's totally blank, my required validator should trigger. So I need to set it to something, so I'm setting it to blank. Then I want to grab the errors. So to make it so my test doesn't fail if the validators didn't fire, the first line says, give me the errors or give me a blank object. Then I'm going to expect the required validator is to be defined, and the min length is undefined. That took me for a loop the first time I ran that. I thought, well, it's blank. That means it's less than 3 characters. The way Angular fires the validators goes, well, required and min length, required takes precedence over min length, so only the required gets fired because you haven't typed anything yet. Then I can test my field validation. So at this point, I expect item field not to be valid, so to be falsy. And I expect my form to also be falsy. Now if I look at the min length validator, very similar. I set a value. This time I set it to single character. And now I expect min length to be defined and required to be undefined. And both fields are still invalid. So I can keep writing. I've got all kinds of tests in my sample code that are doing things with this. Like this one test that required got turned off when I have one field. I have one that has 3 characters, one that has 4 characters to make sure since min length's 3, the validator shouldn't fire. If I get more than it, validator fires. And then I change around the form field validation and the component validation to go, you now should be truthy if I've passed all of this. So you can run all these tests against your validators. I also throw in, typically in these same tests, what should the error for required that I want to spit out be? For sake of brevity, so I didn't have to go through like 8 slides of, here's all of my generic function. Took it out of here, but you can test all the stuff for validation in here. It's really nice to know your form's truly working. There's some gotchas though. Technically, every test I showed you with my generic validator fails when I put the error messages in. Because the first thing that happens, typically for a UI standpoint, you don't want to show your validators unless somebody touched the field and did something with it, which makes it dirty. But set value doesn't set the dirty flag for your field. Instead, you have to do that yourself. So in the before each, since that's where I was grabbing my item field, say item field.mark is dirty, so that it sets that dirty flag and all of my validation can then pass. You also have to call fixture.detectChanges after you set it. It's kind of funny to me that the expect statement here actually passes, but then when you go actually run your real validation, it's still not marked as dirty until you fire the detect changes. And they actually have a comment in their code, thankfully in the Angular code. When you click on set value, it says, we don't set the dirty flag here. You got to do that yourself. And it makes sense that they don't necessarily set it. The dirty flag is meant to be a UI action, and we're setting it in code. Flip side, it's a little annoying that they don't set that because it doesn't mirror how the UI works. The other piece that doesn't work, debounce time has issues in testing. Every time I tried to hook it up with the debounce time in, my validation never got fired, and then I would start getting messages like, you still have 1 item left in the queue. I'm like, what queue? I didn't queue anything. For whatever reason, debounce isn't, they have an open GitHub issue that they're on debounce time not working. And we used it in our validation. So the workaround that I found, essentially have to monkey patch debounce time just to say, return the object immediately. So no matter what I set for debounce time, it's just going to ignore it and return the object back. And then all of my tests work as normal. That was one of the biggest gotcha. I probably spent 3 days just trying to figure out why debounce time wasn't working right. So before we move on to services, any questions on forms? So HTTP services. So up to this point, we've only tested forms and components. Services are a little different. Same concept for isolation. You don't want your service to actually call your database or wherever it's getting its data from, but you want to test all the other interactions. So a lot of times we'll do a map to make sure we've got JSON on responses, or we might do some logic in our service to massage the data that comes back. So we still need to test that stuff. But we don't want to test the actual backend, and they provide us a utility called MockBackend. So you need to import a few things from the HTTP. You need base request options, the HTTP response, and response options. Then we need to import from the Angular HTTP testing the MockBackend. Then we're back to our test bed. We don't have to run it asynchronously though this time, because we're not doing anything with templates. So there's no asynchronous code in order to instantiate stuff. In this case, we give our providers. I'm going to provide my service, which happens to be called to-do service. In this big chunk of code, I provide MockBackend. Then I change around our base request options for HTTP. Say provide HTTP. I'm going to use a factory where I say new HTTP. I'm going to provide it our backend and our options. And I'm going to set MockBackend in our base request options. So anytime that you try to make an HTTP call, it's going to automatically override it and put in this MockBackend version of HTTP. Then I need to get access to my service and my MockBackends, create a couple variables. Here I used a little bit different syntax in the injector.get that we saw earlier. I had set my test bed to an actual constant value, so I could just say, get me the to-do service and get me the MockBackend. It's basically pulling out what we injected in. And our test looks a little different. Because we're returning some observables out of this, we're going to run it asynchronous. Then we have to set up our MockBackend. We just tell it, for our connections, we want to subscribe to it. We want to give a response. So in this case, we're going to give an HTTP response back of an array of to-do items. Then I make the standard call that I would expect for my service. So I call the getAll method, I subscribe to it, and in my subscribe, I put my expect statements. So I expect my array to match whatever my mock data array length was. And then I can also say in the second expect that I want my array that came out of my service to actually match my mock data array. And so that's what the toEqual does for us. It will look at every one of the objects that's within the array and make sure that all the properties match. If you are messing around with dates, you have to be very careful how you set your dates in testing. If you say new date, you will get a different date out of your initial mock data than what you get from your service, and your equal test will fail. Typically, you have to actually hard set dates when you do testing to some predefined value so that they're the same across mocking as well as across the service. It's a pretty easy way here with this mock connections to overwrite my HTTP and what comes back for it. I can do all my service testing this way. And thankfully, there's no gotchas in this one. And there's not a lot of stuff to test in services. Most services are pretty lightweight, so you're testing more that if I'm only expecting, like my service, all it expected to come back was it had a .map response.json in there. So it's just expecting that, no logic, so it's pretty easy to test. So questions on services before we go to routing? So our goal with route testing is to test our navigation. It's not to test the Angular router. Which means we want to abstract away all the router complexity, and they give us Angular testing utilities to do that. And it is called the RouterTestingModule. So in our before each async, in our imports, we need to pull in the router test module. And the thing I dislike the most about router testing is you have to define your routes here that you want to play with. I really wish it would pick up our routes that are already defined in our app, but right now you have to define the routes. And one of the things I do typically to cheat so that I don't have to pull in every single component I normally would route to, because I'm only testing, like in the example of login. On my login form, I have a button that says sign up if you don't have an account. I just want to test when I click that, it goes to the sign up page. in that my location says /signup. So I cheat a little and I make my component the same across the board. So in this case, I'm testing my header component because that's where my links happen to be for navigation. So I just load the same component over and over so I don't have to have this massive imports. And from a testing standpoint, pull in a few things. I'm going to spy on my location so I can actually get access to it. I'm going to pull in my location from the Angular common. Then I'm going to look at router link with href. So I can make queries against that to say, give me all of the things I've set up with a router link. And then I can play with them. So we've seen this code so far. Now we're going to variable for location. We're going to get from our injector our actual spy location. Then we're going to get our links. In this case, I'm going to say query all by the directive router link with href. Because it's my menu with navigation, it's going to pull every single router link that I have in my header for me. I can do simple stuff. Well, first I'm going to import a bunch of helper functions, and we'll go through what advanced, expect, path to be, and click the actual code does, and we'll talk about it here in the test. So first thing, I'm going to pull one of the links out. So in this case, I'm going to look that when I click on a link, it's going to take me home. So first thing, grab access to the link. Then you say, I want my path to be equal to the current location equal to nothing because I haven't routed anywhere yet. So that's the most basic test, and I always run that first to make sure something didn't trigger some random routing. Then the click function is actually doing a button click. So previous versions of Angular, like in the 2 space, not the 4 space, they actually had this router test stub or this router stub that you didn't have to click on all of the links to actually test routing. They have gotten rid of that from what I can tell. It's no longer in the generated project, and all of their code samples have comments that say, going to RouterTestingModule in next version. And so, but you don't have to click on the link, and they took the click function away. So click just says, do a left mouse click on this link, which will trigger my navigation. And the advanced, I give it my fixture, it's going to do a tick, and it's going to do a fixture.detect changes so my location, new location becomes active. And now I can test that my location is actually equal to /signup. So I know that that link went to the right location and I wired everything up right. That's the stuff we're trying to test with routing. I have to assume everything else that Angular does for routing just works. I don't want to retest the Angular framework. That's not my goal. But this stuff, because we're typing it in, I have to type in those router links. So it's very easy to get sign up wrong or to put sign up dash space or something else. So this helps me validate my menu works. So we have these 3 helper functions. First one's the click function. We have our click event set up. So we have left, right buttons. It's button 0 and button 2. I'm assuming the middle button must be button 1, but I don't really know. And then we export a function called click that takes in either a debug element or an HTML element to click on. And we can pass in what event we want it to trigger. By default, we tell it trigger the left mouse click, because that's typically what you're going to do when you're trying to do these kind of clicks. Then it either triggers the click if it's type of HTML element, or it's going to call the trigger event handler and call click and pass in our event object. For the trigger event handler, you used to be able to not have to pass in an object. You could just pass in null. That appears to have changed. So previous versions of the click method that they gave you used to just say null for the event object. Now it doesn't go anywhere when it does that. So it's important if you do trigger event handlers in your testing code, you tell it what button it's clicked on. Next we have our advanced function. Takes in our tick in our component fixture so we can trigger changes. We pass in that component fixture. We've already seen our tick code. We're calling tick, and then we're just going to trigger change detection. So it's a nice way to not have to put those 2 lines in every time I need to advance stuff forward. They always go together. The last one's my expect path to be. So this one, taking my location, I'm going to pass in what location am I expecting it to be, or what location is it, then my path of what am I expecting it to be, and then an error message if I want one. If not, it'll just spit out the path that it actually had. And just a simple way to do an expect statement so I don't have to copy this everywhere for navigation. This was getting old copying this expect line for all of my tests, because there's like 8 things that were in my menu. So centralize it. Jasmine goodies. So if I only want to run a group of tests or a single test, I put an F in front of either the describe or the it. I will absolutely warn you, it won't be long before at least one person in your team checks it in this way, and then you wonder why only a small portion of your unit tests are running. I wish there was a better way to do it, but there is not. Yep, you have to have Git hooks and other stuff for that to get around it. Yes, almost every team ends up implementing some kind of a Git hook or something, and so you can't check them in. Until you do that, somebody will check it in. Or they'll do the opposite. If you want to exclude a test, you put an X in front of the describe or in front of the it, and it will skip over that test. That is what, so the question is importing only the modules for the specific test. So both of these ones don't do anything specific for Angular, the X and the F, or Jasmine specific, but the the TestBed configure testing module is what you use to pull in only the stuff you need for your specific test. You can also group tests together. So we have our standard describe that we've been looking at. We can pull our setup out, which is just our before eaches, both our async and our normal one if we need them. But then you can do stuff like multiple describe statements. And each one of these can have its own before each. As we can see here in our navigation test, that's where I can go look at all the links. So in some cases, I don't need to do certain stuff in my before each for some tests. Like my create test, all it's doing is making sure my component's truthy. I don't need to go get navigation links and go mock out services and all that stuff. So it's just a nice way to separate stuff out and group them together. And it makes it really nice for the F describes that if I only want to test the navigation, I don't want to run all the other ones, I don't have to go test by test in there. I can just do the one describes. Great way to separate out code by functionality for testing. So wrap up here. Unit tests are just proof your code does what you think it does. They ultimately will make you faster. They will confirm the functionality of your app. It allows you to check your regressions as well. As you get more and more tests into your suite, as you make a change, you can test everything to make sure you didn't break some random thing that you weren't even realizing. Also allows you to pinpoint bugs since it points right to the errors. You can quickly find some random bug that you put in, like the case of hello world with the punctuation having the space before it. Like, that quickly was pinpointed without the user seeing it. Also a great way to document your functionality. You get a new member on your team that's wondering what the app does. They should be able to read through your test and figure out, oh, that's what this component does, and this is the kind of inputs and outputs I'm expecting from it. No longer do you have to write all of these crazy code comments just to tell them what it does. Just go look at the unit test. I love this quote by Martin Fowler. It says, "Don't let the fear that testing can't catch all bugs stop you from writing the test that will catch most bugs." Our goal is never 100% test coverage. Let's just be honest, if you get 100% test coverage, you probably have a whole slew of tests that aren't doing anything of value. Focus on the ones that are of value. Shoot for 75, 80% of it. A few resources for you. The Angular unit testing guide has tons and tons of info. It's like a 140-page guide that goes through all kinds of stuff. All the stuff I've gone through is in there, plus all the stuff for pipes, all the stuff for guards. There's a whole lot more. There's a nice Jasmine intro. It will go through all the different expect statements. There's like 8 to 10 of them. And they have lots of different code examples on the Jasmine site. The code samples that you saw in here are actually available on a GitHub repository. They're part of my Angular workshop code. Unfortunately, I don't have a chapter written yet for unit testing. That will happen sometime before October when I give the workshop again. And all of these slides are already available on slideshare.net. I will also tweet out the slide link right after this talk so that you have it. Need to get a hold of me? Lots of places. Contact form on my website. I'm on Twitter at DigitalDrummerJ. You can find me on YouTube, DigitalDrummerJ. I'm also on Twitch at DigitalDrummerJ. I will take any questions up here afterwards, since I know we're butting up against lunch. Let us say thank you very much.